Let's not forget that in C++, everything must have a unique name or keyword or whatever to identify what are we trying to do. As I explained, you cannot make a integer variable whose name is int, because int is a special keyword which is reserved for creating integer variables. Along those rules is also you cannot create two variables which have the same name. As a matter of fact, the compiler won't look at this like creating two different variables having the same name. The compiler will understand this like trying to create the same variable again, which doesn't make sense. The variable already exists. Why are you creating the same thing again? Having said that, let's look some more into the rules of scope and visibility. Here is my main function, which I prepared before, and here I also prepared a different function called myfunc. So let's step through it step by step and see what's going on. At first I'm creating a variable x. So of course x will only exist as long as this block of code over here exists. To make sure, we're just going to print out over here that in the main function the variable x is whatever it is. Then we skip over and call my function. So let's see what my function does. Over here I am creating again a variable x. And this is perfectly okay. This won't be a problem to the compiler. It's not going to look like I'm creating the same variable again, because this x over here is existing in its own scope world right over here, and this x doesn't see that. It has nothing to do with that world of the main function. This is a brand new world, the myfunc world, so it can have its own scope, which has of course the opening and closing brace, and it can have its own variable x because it's a different world. Go ahead and try it out. Your compiler will compile this with no problem. And just to make sure, we are printing out over here whatever x has. In myfunc, the local x has whatever it has. By local, I mean that this variable exists in my local world, which is this one over here. There are other remote worlds out there. There's the main world, there is another world over here, as we're going to see in a minute, but in our local world right over here, in this function myfunc, we are creating our own x variable, and it has 8 as is being printed out. So basically we teleported from this main world to a different myfunc world, and anything in the main world at this point is entirely irrelevant. It doesn't exist. If I start using some x variable, I'll get a compiler error because we don't know what this x over here is. We never declared it, we never created it. We have to create our own variables over here to be able to use them. Now here in our local world we open up a even inner world, a inner scope. As I explained, anywhere in your code, if you want to make things a little bit more organized, you could just store things inside of a block of code with the opening and closing brace. But the side effect of making this block of code is that all the rules of scope and visibility apply. Now, because we haven't really teleported from one world to a different world, we were just in our world and we stepped inside a more closer, a more inner nested world. Because we did that, any variables which existed before in the outer scope over here can still be visible to the inner nested scope. As we see over here, I'm printing out that in the block of code which is inside myfunc world, x is, and we are using the variable x over here. So if you wonder, wait, but what is x? We entered a new world over here, we have to make our own variable x's. Yes, but we didn't really teleport from one place to another. When we came from main to myfunc, that was really like teleportation. So we're a bit more separated of that main world than if we are in our own world and we just step inside a nested world. So it's a little different. Inside of this inner world, we can still see stuff that we created in the immediate outer local world. As you see, you can go ahead and compile this and you'll have no problem. The compiler will understand that this variable x is what we created outside over here. Now, what in the world is going on over here? This should apparently be a clear-cut C++ crime of creating two variables with the same name, and it should be a compiler error, because why are we making the same variable again? If we could see the variable x, which means it's still visible, it still exists, how can you create a different variable called x? Well, that's the effects of stepping into a inner scope. You can take advantage of outer variables as much as you'd like, and yet you can still create your own local variables, even if they have the same name as outer variables, because in a way you still did go to a different world. So this compiles over here with no problems whatsoever. So what happens right now? We have an outer x which has 8, and we have a local inner x which has 9. So if I try to use x, what does it have in it? 8 or 9? Well, the rules are that once you step into a more local scope and you create a local variable which has the same name as another visible outer variable, you completely block out from that point on the visibility of the outer variable. So even though at this point the outer x was still visible and we actually used it in our inner world, but from this point on that variable x will be completely blocked out from our visibility, and the only thing that we'll be dealing with right now in our inner scope is the brand new variable x, which we gave it 9. And to prove this, we print out that our very local variable x, I call it very local because we have this locality over here, and then we have an even inner locality right over here. We have a world nested inside of a world. So in the very local world, in the very inner world, x is, and as we'll see, it'll print out the number 9, even though just a minute before x printed out the number 8. Okay, now we reach the closing brace, so we are stepping out of this small world over here, and we're getting back to the real world of this outer scope over here. At that point, this variable x over here disappears. As I explained in the last video, that any local variables will be destroyed as soon as their scope, their little world, finishes. So this inner x is being destroyed. However, of course, the outer x will still exist. And not only that, but anything you did to this inner variable x inside over here, like we gave it the number 9, this has nothing to do and will never affect the outer variable x over here. And we prove that by printing that out of block, when we finish this code block over here outside of the block, still inside of my func, the variable x is whatever it is, and as we'll see, that will be the number 8. And now our function comes to an end by the closing brace, and we come back to where we came from. And along with that, anything that ever existed, that ever was created inside of this world over here, of course, inside of this world over here, and even inside of the whole world of my function, everything gets destroyed. So this x was already destroyed before, but now even this x over here will be destroyed along with the whole world of my func. And we come back to where we came from. And if you haven't forgotten, we got our own little integer x over here, which has neither 8 nor 9, this has 5. And just to prove that it wasn't changed by anything that happened in that other teleportation world, I print that back in main, x is equals to whatever it is, and of course that will be 5. Let's see it happening. Here we go. In the main function, x is 5. In my function, the local x is 8. Inside the block of my function, x is 8. And then the very local x, which blocked the visibility of the previous x, is 9. Then we went out of the block. In my function, it's 8. And then back in main, the local x is 5. So make sure you review and understand what variables exist when and where, which scope do they belong to, are they visible or not, can I use them, can I refer to them, because I can't refer to a variable that was never created, that's a compiler error. How long will they exist, when will they go out of scope, when will they be destroyed, etc, etc, etc. Very important to understand this in C++.